Hello guys, this is CodeNCode, and in this lecture we are going to solve this problem, that is Bugs Life from Spoj, and this question would utilize the concept that we have learned in the previous lecture, that is bipartite graph. So the question is, there's a professor and he's researching on a sexual behavior of a rare species of bug. He assumes that they feature two different kinds of gender and they only interact with bugs of opposite gender. So there are bugs, and the theory of professor is that there are two different kinds of gender among those bugs and they only interact with opposite gender bugs. So in this experiment, so basically we are given we are given n the number of bugs. It can be as large as 2000, and there are their interactions, that is a million. So we are given t test cases, and in each test cases we are given n and m, that is number of bugs and number of interaction between them. So we have to tell whether this forms whether the theory of professor is correct or not. That is, the bugs, uh, there are two different genders. The theory of professor is that there are two different genders and the bugs only interact with opposite gender bugs. So whether the theory of the doctor is correct or not. So for example, the given test is this: there are three bugs and three interaction. One is interacting with two is interacting with three, and one is interacting with three. So if you look at the test case, it would be look something like this. It will be looking something like this. So bug 1 is interacting with 1 and 3, sorry, bug 1 is interacting with 2 and 3, while bug 3 is also interacting with 2. So is it possible that there are two opposite genders? In this example, the answer is no. Suppose this was male, and since this is male and it is interacting with 3, then this have to be a female, and similarly for this. So 3 and 2 becomes female, but since they are also interacting with each other, it it goes against the theory of professor, which states that yep, they only interact with opposite gender bugs. But here female and female interaction can be seen, or the same gender interaction is we can see. So this is this scenario doesn't verify both the theory of professor, and hence in this case we have to print suspicious bugs found. While in the second case, when there is given there are 4 bugs and 2 interaction, one is interacting with 2 while 3 is interacting with 4. So in this this is the complete graph of that. So we can see we can assign this this bug a single gender, and then this bug opposite gender of that, and this verifies both the theories of professor. Same goes for this. So there are no interaction which goes against the theory of the professor, hence we would write no suspicious bugs found, and that is what we have to output, no suspicious bugs found. So what we have to do, we have to check whether the whole set of bugs can be divided into two categories, one of one type of gender and another set for another type of gender. So you can see this clearly goes for the bipartite graph test. If the given graph can be categorized as bipartite, so the one which lie in the single set can be categorized as gender 1, while the other can be categorized as gender 2. So the question, the given question boils down to a single question, whether the given graph is bipartite or not. That's what we have to see. And one more thing, there can be more than one connected component, so we have to see for every connected component. For example, this, in this example there was only a single connected component, while in this example there are two connected components. So we have to make sure that none of the connected component goes against the theory of doctor or professor. If even a single connected component goes against the theory of professor, then we will print suspicious bugs found, otherwise no suspicious bugs found. So let's just dive into coding. Let's define the adjacency list. Since there are 2000 bugs, so I'm taking an array of 2001, and then visited array, and there are t test cases, n m a n b. No, we have to go for the for loop because we have to print the test case number as well. So for each test case we have to print scenario number 1 or 2 or 3. So tc test case is equals to 1. We read n and m, the number of nodes and number of bugs and number of interaction, and then since there are t test cases, so it is important for us to clear the adjacency list of each node, because the adjacency list may contain element from the previous test case. Since there are more than one test cases, so it may happen that the node number 1 contains some element from the previous test case. That is why it is important for us to clear the adjacency list before starting to read edges and inserting or building the adjacency list. So that is why I'm clearing all the nodes from 1 to n, and then just read the introductions. In the adjacency list of A we insert B, and in the adjacency list of B we insert A. We already know all these stuff, so I'm not explaining. If you do not know, this is just a adjacency list representation of graph. You can check out in the previous video what it is, and you can see the explanation of that. After we have built the graph, the important thing is to check for each, and since there are t test cases, in each test cases I have to reset the visited array value as well because it may also contain the value of previous test case. That is why you have to reset the values of adjacency list as well as the visited array. Now after doing that, let's define a bool array which says yep, everything is correct, or bool flag true, indicating that yes, the theory of professor is correct. And from starting from node 1 to n, if the ith node is not visited, which means this connected component has not been tested for bipartite test, so we would make a DFS call to this node passing the color 0. And I have already explained this bipartite testing, and it would return result as well. So since DFS call returns you whether the connected component is bipartite or not. If it returns false, that means it is not bipartite. So if it returns false, which indicate that yes, the theory is incorrect, and hence we would make the flag as false. So first of all we have to print scenario, I guess. Yes, scenario number test case. So this is scenario number, and then after that, if flag is equals to false, then we have to print suspicious bugs found. So let's just copy let's just copy this. I don't know what's happening. Come on. Okay. I'm lazy. So suspicious bugs found, and yeah, we have, else we would print no suspicious bugs found. Let me check. No suspicious bugs found, it is small s, and after found we have an exclamation point or mark, whatever it is. After that just turn 0, so it should work. Yeah, we haven't defined the DFS. function. So dfs would return bool, and it takes two parameter, node and color. And yeah, we need another array to save the color. So as soon as we land, we mark the current node as visited and set its color to be it's node. So we have marked it visited and also set its color. Now in the adjacency list of this node, there are two cases. If maybe the child is not visited, in that case we would make a dfs call to that child, passing the color just opposite the current node color. And if that node tells yep, it has found that the graph is not bipartite, hence it would return false, and hence result would be false. So if result is false, we would not continue our execution and return from here, and we would also return false, yep, indicating that the graph is not bipartite. And if the child is not visited, if the child is visited, then we would compare the color. We would compare the color, and color of current node is equals to color of child. If they both are having the same color, which indicates that the graph is not bipartite, and we would return false. Else, if the whole execution executes successfully, if this part executes successfully, which indicates that the graph is bipartite, and we would return true. So this should do the trick if we haven't made any. Oh yeah, sorry. So let's see. Let's simply run this. Scenario number 1, suspicious bugs found. Scenario number 2, no suspicious bugs found. I hope we don't get any error while submitting it. So let's just submit and see what is the result. C++14 GCC compiler. Let's submit. I don't know why. Yeah, most of the time I guess get nervous, and yep, we get accepted. So this is how you solve this problem. The problem might tell you that what are the scenarios where bipartite graphs can be used. There is one more problem. I would search for that. I have solved that problem a long time ago, and that was more interesting than this, and that was related to mathematical equation where the bipartite graph were used. So I'll see if I can find that problem, and till then you can find yourself what are the problems that involve bipartite graphs and try to solve those problems. So I hope you have learned something from it. So thank you guys for watching, and yep, keep coding. Thank you.